Good morning, students. How you doing today? Mr. Elliott here, but not exactly here. He's not feeling very well. I am not feeling very well. So I'm not going to be in school today. Um, so just some general announcements, because I won't be in school today on January 10. We had a quadratic formula quiz scheduled today. That will now be on Wednesday. That's tomorrow. Several students scheduled a test retake today. You have two options. You actually have three, I suppose. You could do the test on Wednesday morning. That's tomorrow at 8:30 a.m. If this interests you, you need to meet me in room 3103, and you need to be on time. If you show up at 8:32, 8:33, I will have already moved on, and I'll be doing something else. So you need to show up at 8:30 if you're interested in this test retake on Wednesday morning in room 3103. Another option is just to take it Thursday after school. Just to talk schedule for a couple minutes. Today, you should be working on solving quadratics using any method. There's also the chapter 7 review for you to pick up today. You might want to get starting on that today. We normally have a 2-day review, but I only put a 1-day review in the schedule, so you might want to put in a little extra, start that review today, so you can get all those questions answered tomorrow. And then we'll have that chapter 7A test on Thursday, and then we'll start preparing for the final exam. So anyway, I was going to do this spiel in class today, but I'm not going to be there. So what do they mean when they're talking solving quadratics by any method? Well, there's kind of 3 different techniques that we've used over the last couple weeks. There's basic algebra, stuff that we actually did before Chapter 7A. I would only use basic algebra if it's already in vertex form. It is true that you could always change your equation from standard form to vertex form, then use basic algebra if you're really good at completing the square. But to me, that seems like a lot of work, and I wouldn't do it. But if you're going to use basic algebra for one like this, set equal to 0, you'd first add 42 to both sides, and then you'd divide both sides by 42, and you divide both sides by 3, and 42 divided by 3 is 14, equals x plus 1 quantity squared. Once you've isolated the thing that's squared, you can square root both sides. You get x plus 1 equals positive negative root 14. You'd subtract 1 from both sides, and you'd essentially end up with negative 1 plus or minus square root 14. That's your basic algebra problem. It can have different looks, but this is essentially what it usually looks like. I guess the hope is that you know the square root of this number, but you're not always going to know the square root of it. Then there's factoring. I use factoring when I look at an equation and I'm like, all right, I need 2 numbers that multiply to 6, yet add up to 7, and you're like, oh, I know that, and you know it right away. So you're a good factorer. This factors into x plus 1 and x plus 6, and then you set both of those equal to 0, and you get answers of negative 1 or x equals negative 6. So factoring. I use factoring when I look at the equation and I know right away that it is factorable. I use quadratic formula when I look at it and I don't know if it's factorable, or maybe it's a hard to factor. This is actually a pretty good situation. I don't want to have to think about numbers that multiply to 8 and then also numbers that multiply to 4. It's just a lot of work, and at the end of the day, it might not be factorable. So I would use quadratic formula in one like this. Negative b, so positive 3 plus or minus the square root of b squared 9 minus 4 times 8 times negative 4, which is positive, 16 times 8. 16 times 8 is 128, all over 2 times a, which is 16, and here I end up with 3 plus or minus the square root of, 1 137 all over 16. Square root 137 cannot be simplified, and I'd actually be done there. So just using quadratic formula. So on this worksheet that you're going to be doing for your homework tonight, I would use one of these three methods. And I'm also just going to quickly just look at this and tell you, what would Elliott do if he was going to solve these ones? You don't have to follow my advice. I'm just telling you what I would do to solve these. Number one here looks a lot like basic algebra, so I'd be using algebra for number one. Number two, it looks like it's decently easy to factor, but you would need two numbers to multiply to 6, yet also add up the 6. That doesn't exist. This one's not factorable, so I'd have to use quadratic formula. This one, number 3, two numbers that multiply to -2, yet add up to -5. That doesn't exist. I'd use quadratic formula. Let's see, this one. The two numbers are going to multiply to 60. Let's see, what are the ways? Okay, this one's factorable. It's factorable, but it's a harder one to factor. So if you're a good factorer, I would use factoring on this one. But if you're not a good factorer, I would use quadratic formula. So factoring if you're good at it, or quadratic formula if you're not good at factoring. Let's see, this one. When I add 10 to both sides, I'm going to get a -26 here. Okay, now actually, this one's actually a little bit of interesting. So if I set it equal to 0, I get 2x squared plus 24x minus 26 equals 0. Now, it doesn't look very friendly, but I notice everything's even. If I divide everything by 2, I get x squared plus 12x minus 13 equals 0. And now as I look at that, I'm like, oh, this one's totally factorable, and it's easy to factor. So I would use factoring. But if you're bad at factoring, you should probably just use quadratic formula. Number 6, this is actually a lot like number 1. I would just use algebra to solve this one out. Number 7, multiply to -55, yet add up to 6. 11 and 5. I would use factoring. Factoring multiplies to -12, yet adds up to -1, 4, and 4, or -4, positive 3. This one, that's a perfect square trinomial. Factoring. 10. X minus, this one's factoring. This one multiplies to 4, yet adds up to 1. That doesn't exist. I'd use quadratic formula. All right, I think I'm going to stop there. The gist is that you can choose a lot of different things. If it's easy to factor, use factoring. Factoring is the fastest way to go. If you're a bad factor, you can always use quadratic formula. You can always use basic algebra for every single problem, but if you did, you need to be able to take this equation here, change it into vertex form, then solve it using basic algebra. That sounds like a lot of work, especially when I look at that and know instantly that it's factorable. So enjoy this homework tonight, everybody. And I'm really sorry I'm not able to be there today. But, you know, things happen. So have a good day, everyone. And I will talk to you on Wednesday. Bye-bye.